Hello, so this is your Plate Boundaries digital notebook. I am going to go through this just in case you are absent or need to hear any of the notes verbally again. So let's get started. So for our essential questions, we have what is plate tectonics? Number 2, what are the 3 types of plate boundaries? And number 3, what crustal features are formed at plate boundaries? Now on the left side, you'll have reflect on the essential questions before you dive in. These are prior knowledge questions, so it's okay if you don't know the answers to them. But the first question is, if you were quizzed today, which questions would you already know the answers to? And number 2, which questions would you need to learn more about to answer confidently? After this PowerPoint, hopefully you are able to answer all of the questions confidently. So let's get started. So over time, the continents have shifted to their current positions. If you've ever heard the term Pangea, millions of years ago, all these 7 continents used to be into one big landmass. And over time, they've shifted into the 7 continents that we know today as North America, South America, Europe, Africa, Asia, Australia, and Antarctica. So the question to the left says, why are the continents of Europe and Asia different than all of the others? So if you look at all the other continents and how they are distributed in the Earth, if you look at Europe and Asia, how do they differ comparatively to the other continents? Take a second, type your answer in the space provided, and we're going to move on. So plate boundaries is actually a pretty recent topic in science. It wasn't widely known before these 2 scientists came along and had their theories develop that we really had any understanding of the continents and how they've shifted. So the first person, continental drift theory, was developed by Alfred Wegener, and he developed the theory that the continents drifted. He was the first person to really notice that there were similarities in continents and what kind of things we find there, even in continents that are really far apart. So at the time, he didn't really understand how this happened or why it happened, but he knew that it was happening. So between Alfred Wegener and Harry Hess, who had the seafloor spreading theory, the 2 of them kind of developed this plate tectonic theory that we know today. So Harry Hess discovered that magma was rising on the seafloor, causing it to spread. So the hot magma rising in the mantle caused the spreading on the seafloor and the large pieces of crust known as tectonic plates to move. So as these plates separated, magma was flowing to the surface. And as magma cools, it becomes hardened. So if you think of a volcano, if you've ever seen pictures of a volcano that's erupted, you're not going to see bright red lava the entire time. You're going to see some dark hardened magma, and that eventually becomes crust. So when it's under the seafloor, it creates this crust. So it kind of regenerates itself under the ocean. So the plate tectonics is a theory that Earth's outer crust, called the lithosphere, is divided into several plates that glide over the plastic-like and less rigid asthenosphere. Sorry, you're going to hear me mess that word up a couple times. So that's the upper mantle. It was discovered and developed from the 2 previous theories that we had just talked about. So between the 2 scientists we talked about, their theories kind of got combined and turned into the modern day plate boundaries theory that we know today. So we knew eventually, so back when we were looking at Alfred Wegener, we knew that the plates were moving. We didn't really understand how, and Harry Hess kind of gave us the how the plates were moving. So the upper crust of the Earth is called the lithosphere, and it's divided into those plates that we call plate boundaries or tectonic plates. Underneath of it, you have the asthenosphere, and that's a more plastic-like. It's not as rigid. It's a little more fluid in its structure. So the question here are the 2 scientists accredited with these theories are, and if you don't remember, on the slide previously, we have Alfred Wegener and Harry Hess. Now, this slide asks you to give a couple definitions. So write a short definition for the term lithosphere and asthenosphere. So the lithosphere, if you would recall, is the outer crust of Earth. So it's Earth's outermost crust, but not the continents and not the ocean. So it's the crust that is underneath of the ocean and our land masses, known as continents. The asthenosphere is the upper mantle. Now I'm going to show you this on this picture. So if you look, you will see blue because that is the ocean, and you will see some tannish colored earth. Now that's the earth that we step on. The lithosphere and the asthenosphere are not what you actually touch. It's not what you actually step on. You don't actually step on tectonic plates. The tectonic plates are underneath of the earth that we stand on. So it's kind of like we're on an island almost, kind of. So the lithosphere is this upper crust, and that's what makes up underneath the seafloor and the mantle there. The lithosphere is this upper solid mantle, and then the asthenosphere is this lower mantle that's in light orange. And that's a little more flexible under Earth's surface. The crust is a little more, or the lithosphere, that's a little more solid. Now, all of these plates that move around under us, there are 7 major plates. Now, if you think about it, we have 7 continents in the world. So the major plates that we would consider to be major are the ones that are named after continents. So if you look at this map, you'll see that there's the North American plate. We live in North America. There is the Eurasian plate. The Eurasian plate is a combination of Europe and Asia, the continents of Europe and Asia. We have the African plate, which takes up the African continent. We have the South American plate. We have the Australian plate. This giant plate here is called the Pacific plate, this light yellow one. That's not a continent, but we consider it to be major because of how large it is. And then the last large considered to be major plate tectonic is the Antarctic plate. So just to reiterate, we have the Antarctic plate, the Pacific plate, the Australian plate, the North American plate, the South American plate, the African plate, and the Eurasian plate. They make up our 7 major plate tectonics. The rest of the plates are considered to be minor because their size is way smaller than our major plates. So we have some of those, and I'm just going to go over those now. So our minor plates include the Philippine plate, the Cocos plate, the Nazca plate, the Scotia plate, the Arabian plate, the Indian plate, the Caribbean plate, and the Juan de Fuca plate. If you need to pause this just to look and make sure you get all the names down, make sure you're looking at all of the smaller plates that I just listed. Now, when we think about plate boundaries, we say that they're moving under us, but we haven't talked about why. So what is the engine that moves these plates? They're moving for some reason, so now we have to learn why. They're moving underneath of us because of something called a convection current. So underneath the Earth, there's heat that comes from the inner core of Earth. So you've probably heard that there's magma underneath of the soil, like when you dig way down under the asthenosphere, there's a lot of heat from the magma. So what happens during these convection currents is heat is transferred from the mantle. And what happens is that heat will rise. So the hotter magma will rise to the top of the mantle, and as it flows down, it begins to cool. So as it's cooling, it's traveling back towards this hot center of the Earth, and it's going to heat up again. So if you've ever heard if you live in a multiple story house, heat always rises. So this is true for the hot magma as well. So when the magma is hanging out by the center of the Earth, the core, it's going to heat up. And when it heats up, it wants to rise. So as it's rising, it's further from the center of the core where there's less heat as it moves away from the core. So naturally, it starts to cool off. So if you live in a multiple story house and you go upstairs, it's warmer. But as you travel away from that heat, you become cooler. The same is true for this magma. So where might you have heard the term convection before? I know me personally, I've heard the term convection oven, and Sometimes that's referred to as like a microwave. You've heard it called a convection oven. So take a second and think of where else you might have heard the word convection. So this is where we would typically stop for day 1. So if you are listening to this and you are taking notes, this would be the end of day 1.